Hello everyone, this is video number 4. In this video we're gonna find an expression for a linear function. Okay, exercise number 1. It is given that we have two coordinates, or you can call it points, and those points or coordinates are actually belong to some linear function, and we will need to find a linear function. You can see here, you can call it a formula to find a linear function. The first step, we're going to calculate the slope, which is m equals delta y over delta x, where delta y is y2 minus y1 divided by x2 minus x1. Okay, y2 is actually minus 2 minus y1 divided by x2, which is 8 minus 2 x1. Okay, let me check for the errors. Y2 is minus 2 minus 1. Okay, x2 is 8 minus x1 is 2. Okay, looks like okay. A minus 3 divided by minus 6, no, plus 6, I'm sorry, and we get minus half. This is our slope. Now we have the slope. What we need to do, the next step, you have to choose the fixed point. You can take one out of the two. You can take or A or B. It doesn't matter which you will decide to choose, you will get the same result. Let's assume that your fixed point will be A. Okay, so A equals x0 equals 2, y0 equals 1. So now we can find finally expression for a linear function. Minus half times x minus 2 plus 1. Let's open the brackets. Minus half times x plus 1 plus 1. And there you go, we have minus half x plus 2. This is our linear function. Now we also maybe will want to draw the graph of this linear function. You can take actually any 2 points that you want to draw this graph. Okay, actually we can take those 2 coordinates. Okay, it is always enough to use 2 coordinates and to draw a linear function between them. In this case, let's draw y-axis and x. We can use those points that we've been given, which first one is A, x1 is 2, and y1 is 1. This is our first coordinate, is A, here. Second coordinate, B, x2 equals 8, 3, 4, 5, 6, 7, 8. Okay, and y equals minus 2. And this is A and this is point B. Okay, now we'll take straight line, okay, and we have this linear function. Okay, next step, we can find crossover points between this linear function y equals minus half times x plus 2 and between this linear function and y-axis, which is this point, and x-axis, the second point. And how we can do that? Let's assume we want to find crossover point between linear function and y-axis. To do so, we actually say that in this case we should use x equals 0, because in this case, when you look at this point, which is a crossover point between linear function and y-axis, x equals 0. That's why I use x as a 0 plus 2, which means when x equals 0, okay, we get y equals 2. Okay, so this point, crossover point, is a crossover point between the linear function and x-axis. Now we want to find second crossover point between linear function and x-axis. I'm talking about this point here. Okay, this point. Now, as you can see, in this case, when you look at this point, y equals 0. So we take this function here, y equals 0. Okay, 0 equals minus half x plus 2. Therefore, we have x equals 2. Therefore, x equals 4. This is our second crossover point between linear function and x-axis. Okay, exercise number 2. Again, we have 2 points or coordinates, and we have to find linear function, expression for a linear function. Again, the first step, we have to calculate the slope, which is y2 minus y1 divided by x2 minus x1 equals, okay, y2 equals 1 minus y1. y1 also equals 1. Okay, divided by x2, which is equals 3, minus x1, which is equals 1. And what do we get? We get 0 divided by 2. Okay, how many times 2, okay, can be included in 0? 0 times. Interesting, we have 0 slope, which means there is no angle between x-axis and the linear function. But assume we don't see it right now. Again, we use this formula for general linear function, and we choose any point you want as a fixed point. Let's assume it's A. x0 equals 1, y0 equals also 1. And again, m, which is a slope, equals 0. Now, y equals 0 times x minus 1 plus 1. As you can see, this expression gives us 0. 0 plus, I'm sorry, this is not y, equals 1 plus 1, and we have linear function y equals 1. Now, how can we draw the graph of this function? First, let's draw the y-axis, y and x-axis. Okay, we actually seen that the slope is 0, and how can I draw this y equals 1? It appears to be, okay, that no matter what x is, y is always 1, which means we will get this kind of a function. This goes to infinity, plus infinity, I'm talking about x, and this goes to minus infinity. And this value of y is always 1. For any x you will use or take, you will get the same result for y. Okay, and as you can see, in this linear function, the slope is 0, which means the angle between x and the linear function is 0. Example number 3. Okay, we have the slope and a point, which means we don't have to calculate the slope. One less step. Again, we will write the formula of a general linear function. Of course, in this case, you have only one choice for x0 and y0, which is a. M is given, -2. So, what we have? We have y equals -2 times x minus -3 plus 1. Let's open the brackets. Minus 2x minus 6 plus 1. And then we have y equals minus 2x minus 5. Okay. Now the last step, we need to draw the graph. Y axis and x. You can choose any 2 points you want. I will choose first point. I would insert x equals 0, minus 2 times 0, minus 5, which means we have this point. It's called A, no, it's called B, equals x equals 0, and y equals minus 5. We already have another point, -3, and y equals 1. Let's copy this point, copy and paste, and there we go. We have 2 points, and it is enough, 2 points, to draw a straight line between them. Okay, let's take and draw the first coordinate, 0, -5. Let's move this whole expression here, because we need more space to add this coordinate of B, which is 0, -5. 1, 2, 3, 4, 5. This is actually our point B. Second point, A, x equals -3, 1, 2, -3, and y equals 1, 1. This is point A. And there you go. you can draw this line. Okay, got 3 here and 6 points. 1 2 3, 1 2 3 4 5 6, like this. And there you go. There is your function of y equals minus 2x minus 5. There's that's the graph. Okay, now we already found this crossover point between the linear function and y-axis, which is actually point B. We can also ask ourselves, what is the second crossover point between linear function and x-axis? In this case, we need to insert y equals 0. Okay, this is our linear function, an expression. Copy, paste. Okay, to find our second crossover point, we should use y equals 0, and therefore we have 0 equals minus 2x minus 5, and we have x equals minus 5 divided by 2, 2.5 minus. If this is minus 1, minus 2, this point is minus 2.5. This is your second crossover point between linear function and x-axis. And the last example, again we have the slope, which means one step less, and a point that actually belongs to some linear function that we're going to build. Okay, again, our formula y equals m times x minus x0 plus y0. Okay, so in this case, again, we don't have really much choice but to choose x0 and y0 as point A. Y equals 1 times x minus 1 plus 1. Let's open the brackets. X plus 1 plus 1. And therefore we have y equals x plus 2. And this is our expression, mathematical expression for a linear function. Okay, next step we will have to draw this function as a graph. X, y. Okay, which shows minus 1. Okay, let's assume x equals 0 when x equals 1. Then y equals 1 plus 2 equals 0. So we have one point B equals x1, y3. And we'll use this as a second point. Let's copy it. And add them to the graph. Okay, x minus 1, minus 1, and y equals 1. So this is our point A. B, x equals 1 and y equals 3. This is our second point. And this is how our graph will look like. Again, we can ask ourselves what are the crossover points between linear function and the x and y axis. Okay, let's find first a crossover point between x-axis, okay, and linear function. I'm talking about this point here. Okay, so we have to use y as a 0. Therefore, 0 equals x plus 2. Then we have x equals minus 2. So crossover point is minus 2, 0. I'm talking about this point over here. Now the second point, crossover point between linear function and the y-axis, I'm talking about this point here. In this case, equals x equals 0. X equals 0. Therefore, we have y equals 0 plus 2, which means y equals 2. And the second crossover point is 0, 2. I'm talking about this point over here. And that's it. I think that those examples are good enough in the future, okay, to build our linear functions that will demonstrate some physics phenomenon, okay, like one-dimensional movement, velocity, position vectors, acceleration, forces, etc. Okay, now I'm gonna stop here and hear you later.